Two strips of metal stuck in your backyard can generate more reliable power than solar panels. Fechner proved it in 1841. The US Telegraph Company powered cross-country communications with buried copper zinc cells for decades. No sunlight required, no wind needed, no fuel consumed. Just electrochemical reaction between common metals and earth that continues indefinitely. Not because it stopped working. Not because better technology replaced it. We stopped using earth batteries because a power source that generates electricity for free cannot be metered. It cannot be billed. And a household that powers itself from buried metal is a household that cannot be controlled. This is the story of the earth battery, the power source that outlasted every empire that used it, and the industry that spent billions making sure you never learned it was buried in your own backyard. Welcome to Lost Build Archives. Before we open this archive, if these forgotten techniques matter to you, the best way to preserve this knowledge is simple. Subscribe, hit the bell, and share these archives with those who need to remember what we forgot. The archive opens in Leipzig, Germany, 1841. Gustav Fechner, physicist and philosopher, conducts the first documented galvanic earth battery experiment. He buries copper and zinc electrodes in moist soil and measures continuous electrical current. What he discovers is revolutionary. Dissimilar metals in earth create a permanent voltage differential. The reaction continues indefinitely as long as soil moisture exists. His findings would soon revolutionize long-distance communication. The principle spreads across continents like wildfire. By 1844, Samuel Morse is using earth batteries to boost telegraph signals across long distances. By the 1850s, the US Telegraph Company powers entire cross-country lines with buried copper-zinc cells. The 1860s see transatlantic cable operations relying on earth battery technology for signal amplification. And by the 1870s, railroad companies have adopted earth batteries for communication along thousands of miles of track. This was not primitive experimentation. This was the backbone of the first global communication network. Telegraph operators could communicate across continents using power generated from local soil. No coal required, no steam engines, no fuel supply chains. Just metal buried in earth, generating electricity from electrochemical reaction, the same principle that would later be called cathodic protection in modern engineering. The physics is so elegant, it feels like it should not work. The galvanic reaction mechanism is beautifully simple. Copper and zinc create a natural voltage differential when placed in a conductive medium. Soil moisture acts as an electrolyte, allowing ion exchange between metals. Zinc slowly oxidizes, releasing electrons that flow toward the copper electrode. Current flows continuously as long as moisture and metal differential exist. Voltage typically ranges from 0.5 to 1.2 volts per cell, depending on soil conditions. Here's what the power industry does not want you to sit with. Modern solar panels require sunlight, complex electronics, and replacement every 20 to 25 years. Earth batteries generate power 24/7, regardless of weather conditions. There are no moving parts to break, no electronics to fail, no scheduled maintenance. The reaction continues for decades using materials that cost under $50. Now the numbers. A single copper-zinc cell produces 0.8 to 1.0 volts continuous output. A series connection of 12 cells gives you 9.6 to 12 volts, standard battery voltage. Telegraph companies documented 30-plus year operational lifespans. Material cost per cell is just $3 to $8 in copper and zinc strips. Maintenance requirements? 0 for the first 10 to 15 years. Compared to modern alternatives, a solar panel system costs $15,000 to $25,000 installed. A battery backup system runs $10,000 to $15,000 with a 10-year replacement cycle. An earth battery array costs $200 to $500 in materials with a 30-plus year lifespan. Grid connection? $50 to $200 monthly bills for 30 years equals $18,000 to $72,000. Then 1882 arrived, and Thomas Edison opened the first commercial power plant. The Pearl Street station in Manhattan changed everything. Centralized power generation created the first electrical utility business model. Monthly billing for electricity consumption became possible for the first time. Investors realized that power generation could create recurring revenue streams. The $2.4 trillion global electrical power industry was born. A power source with no monthly bill became a threat to the entire business model. Earth batteries generate electricity without fuel purchases. No meter can measure power that never flows through utility lines. Households with buried metal arrays need no grid connection. Self-sufficient power generation eliminates recurring revenue forever. The suppression required no conspiracy meeting or secret document. It required something far simpler and far more durable: systematic exclusion from electrical education. Building codes and electrical standards contain no provisions for earth battery installations. Electrical inspectors receive no training on galvanic power systems. Licensed electricians learn grid-tied systems exclusively. Permit processes assume all power comes from utility connections. Insurance and financing create additional barriers. Homeowners insurance excludes coverage for non-standard electrical systems. Mortgage lenders require grid-connected homes for loan approval. Property appraisers have no category for self-generating power systems. Real estate transactions require utility hookups, regardless of actual power needs. Educational suppression completes the picture. Engineering schools teach centralized power distribution exclusively. Electrical textbooks mention galvanic cells only as historical curiosities. Trade schools train students to install grid-dependent systems only. Professional licensing requires knowledge of utility standards, not earth batteries. At some point, the numbers start to speak loudly enough that even the systems designed to ignore them have to write them down. The National Association of Corrosion Engineers is one of the most respected materials science organizations in North America. When NACE produces corrosion protection standards, those standards are not disputed. When NACE documented cathodic protection using galvanic anodes, they confirmed the same principle Fechner discovered in 1841. Every major pipeline, bridge, and underground structure in America uses galvanic protection systems. Additional validation comes from multiple sources. The U.S. Department of Transportation mandates galvanic cathodic protection for all buried pipelines. American Petroleum Institute standards require galvanic anodes for tank farm protection. The U.S. Navy uses galvanic systems to protect ship hulls and underwater structures. NASA employs galvanic cells for long-term power in space applications. The data required to achieve this validation was the same data telegraph companies documented 150 years ago. Continuous current generation from dissimilar metals in conductive medium. Decades-long operational lifespan with minimal maintenance. Reliable performance regardless of weather or environmental conditions. Cost-effectiveness compared to active power systems. But here is what those systems do not control. In rural Alaska, off-grid homesteaders power LED lighting systems with buried copper-zinc arrays. They use 24-cell earth battery banks providing 24-volt DC power with continuous operation through -40 degrees Fahrenheit winters when solar panels fail. No fuel costs, no generator maintenance, no battery replacement schedules. Families living with reliable electricity in locations where grid connection is impossible. The people building these systems are not survivalist extremists. They are engineers, electricians, and homesteaders who read what the industry does not teach. They study 19th century telegraph manuals and modern corrosion protection standards. They test soil conductivity, calculate electrode spacing, and document voltage output. They prove that power independence does not require expensive technology. Current applications are expanding globally. Remote monitoring stations use earth batteries for decades-long operation. Cathodic protection systems protect trillions of dollars in buried infrastructure. Research stations in Antarctica rely on galvanic power for critical equipment. Developing nations use earth batteries for rural electrification projects. Here is how an earth battery actually works in practice, so you understand what you would be building. Materials needed for a basic 12-volt system include 12 copper strips, 6 inches wide by 2 feet long, 12 zinc strips of the same dimensions, or galvanized steel as a cheaper alternative, insulated copper wire for connections, waterproof wire nuts or terminal blocks, and a basic multimeter for voltage testing. The installation process is straightforward. Dig 12 holes, 3 feet deep, spaced 6 feet apart in line. Place 1 copper and 1 zinc electrode in each hole, 18 inches apart. Backfill with native soil, ensuring good metal-to-earth contact. Connect electrodes in series, copper of cell 1 to zinc of cell 2, and so on. Test voltage across the entire array. Should read 9.6 to 12 volts. Connect to low-voltage DC applications. The cost breakdown is minimal. Copper strips cost $80 to $120 depending on current metal prices. Zinc/galvanized steel runs $40 to $60 for electrode material. Wire and connections add another $20 to $30 for basic hookup. Total system cost $140 to $210 for a 12-volt earth battery bank. Performance expectations are reliable. Continuous voltage output 24/7 regardless of weather. Current capacity depends on electrode size and soil conductivity. The system is suitable for LED lighting, small electronics, and monitoring equipment. Lifespan of 15 to 30 years before electrode replacement is needed. Addressing safety and code concerns. Low voltage DC output, under 50 volts, is considered safe in most jurisdictions. No building permit is required for buried electrodes in most areas. The system operates independently of household electrical panel. It can supplement rather than replace grid connection initially. There is a deeper principle at the center of all of this, one that the history of the earth battery makes unusually clear. The electrical power industry has spent 140 years selling you a relationship of dependence. You need their power plants to generate electricity. You need their transmission lines to deliver it. You need their meters to measure consumption. You need their monthly bills to access what they control. The dependence is not accidental. It is the business model. What the earth battery offers is not primarily free electricity. It is an exit from that relationship. A person who buries copper and zinc in their backyard and powers LED lights from soil chemistry is not a customer of the power company, not a ratepayer subject to utility rate increases, not dependent on grid stability during storms or outages, not vulnerable to supply disruptions or infrastructure failures, not generating monthly revenue for shareholders who profit from scarcity. This is energy independence in its most fundamental form. Power generated from materials you own. Electricity produced on land you control. Technology simple enough to build, maintain, and repair yourself. Knowledge that cannot be regulated, licensed, or taken away. The knowledge was never lost. It was just never sold to you. And now you know why. Gustav Fechner buried metal in German soil in 1841 and measured continuous electricity. Telegraph companies powered cross-continental communications for decades using the same principle. Pipeline engineers still protect buried infrastructure with galvanic systems today. The physics has not changed. The earth still conducts. Metal still reacts. Electrons still flow. The question for you is simpler and more direct than any of the regulatory complexity. You are going to power your home this month. The question is how and at what cost and with what degree of dependence on systems you do not control. Resources available for earth battery construction include telegraph company manuals from the 1800s, documenting original installations, NACE standards providing modern galvanic protection engineering data, homesteading forums sharing current earth battery builds and performance results, and soil conductivity testing equipment available from electrical supply companies. The starting point is 2 pieces of metal and a shovel. Copper and zinc buried 3 feet deep in moist soil. Voltage appears instantly and continues for decades. No permit required, no contractor needed, no monthly bill ever again. Which part of earth battery technology shocked you most? Share in the comments. Subscribe now. This knowledge must survive. Next video reveals the building material that outlasts modern options by 40 times.